During this video, we are going to explain how to name acids. First of all, we have to know what is an acid. An acid is a compound that starts with an H, okay? So every time that you have a compound that starts with an H will be an acid. I know that you will say H2O is not an acid, okay, but all the rest of the compounds that start with an H are going to be acids, okay? Acids are going to be classified in two forms as the salts. Acids are going to be hydroacids when they have hydrogen and a nonmetal, meaning that we have only two elements, and oxyacids or tertiary acids when we have hydrogen, a nonmetal, and oxygen. Okay, so this can be called also tertiary acids or oxyacids. The way to name hydroacids and oxyacids is going to be different. The easiest one is for binary acids or hydroacids, okay? Hydroacids are going to be named placing first the prefix hydro and then the name of the ion, changing the ending "ite" for "ik", followed by the word acid, okay? So in this case, if we have HCl, the name of this compound will be hydro, which is the prefix, chloric, which is of chlorine, ending with "ik" and the word acid. Okay, this is only when we have hydroacids or binary acids, when we have two elements and the first one it's an H, okay? For oxyacids or tertiary acids, it's a little bit different, okay? We have to look to the polyatomic ion, see which is the ending of the polyatomic ion, and we will have to change it. If the polyatomic ion ends in ite, we are going to change it for O's, and if the polyatomic ion ends in ate, we are going to be changed for ik, and we add the word acid. So there's no hydro in the oxyacids name, okay? Even though we have hydrogen, we do not write it in the name. We just write the name of the polyatomic ion and we change it. If the polyatomic ion ends in ite, we change it for O's, and if it ends in ate, we change it for ik. For example, here we have HClO2. Okay, it's a tertiary acid or it's an oxyacid because we have three different elements, 1, 2, 3, okay, and one of them is oxygen, okay? So what we have to look for is we have to look for the polyatomic ion, ClO2. If we look in our chart, we will see that ClO2 stands for chloride, okay? Okay, if you don't believe me, just let me see, where is it here? ClO, and I'm gonna point it out with blue again, okay? ClO, it's here, and it's chloride, okay? So the ending is in ite, okay? So now what I will have to do is I will change this ending ite for O's. This ite, just let me point it out. It's ite. I will change it for chlorus and followed by the word acid. Okay, and that's the name of the compound. Let's make some examples in order to see if we are understanding this or to practice a little bit more. Here we have the first one. We know that it's an acid because it starts with an H. Okay, since we have three different elements, okay, this is going to be a tertiary acid. Okay, what I have to do is I have to look to the ending for the ending of NO3. So if I go to my chart, let's search for NO3. It's here at the top. Okay, NO3. Here we have it. Okay, it has to be with blue, I said. Okay, with blue. And it's nitrate. Okay, so it ends in ate. So by the time that I change it to the form of an acid, what I will do is, remember that the polyatomic ions that ends in ite are going to be changed to O's, and the ones that ends in ate will be changed in ik. So in this case, since this is nitrate, okay, ends in ate, the way to name it in the form of an acid will be nitric acid, okay, because I changed ate to it. Let's look to the next one. The next one, we have the name and we have to write the formula, and it says nitrous acid, okay? I know that in the formula, I will have an H for sure at the beginning because it's an acid and all the acid starts with H. What I have to look for is for nitrous, okay? Nitrous means that if I have now an ending of O's, it means that before it was ite, so I have to look for nitrite, okay? If I look in my chart, I will point it out with blue, okay? Nitrite is here, and it's NO2 with a charge of -1. So that's the one that I will search, and that's the one that I will be writing down in my formula. NO2 with a charge of -1, and it's nitrite. Okay, so what I will do is I will write H and O3. I have to check the charges. NO3 is -1, H is +1. So the sum of my charges is 0, so I leave it like that. Since I have 3 elements, this is a tertiary acid, okay? Let's look to the next one. It says hydrosulfuric acid. I know that in my formula I will start, or I will have an H. But since it says hydro in the name as a prefix, I know that it will not be a tertiary acid, because in all the tertiary acids, we do not have the prefix hydro, okay? We only have the prefix hydro when we have binary acids, okay? So just let me change it to green so it's in the same form, okay? So this will be a a binary acid. Okay, so this will be H at the beginning because we have hydrogen. Okay, and now what I have to do is I have to find sulfuric, okay? In this case, sulfuric comes from sulfur. If I look in my chart, sulfur is located here, and it has a charge of -2, okay? So let's see, how do we write it in my formula? Okay, so I know that I will have an S here in my formula, but I cannot leave it like that. I have to check the charges. So here down, I'm writing HS. I know that S has a charge of -2, okay? This -2, remember, that comes from the fact that sulfur is in group 6. It has 6 valence electrons, so it has missing 2 more in order to get the octet, okay? And hydrogen has a charge of +1, okay? So if we look to the formula, we see that the sum of the charges here is not equal to 0 because we have +1 and -2. So in order to make this balance, what I'm gonna be doing is what we call cross charges. I will pass the number, not the sign, to the bottom of the next element, crossing it. So this one will go here. This 2 will go here, only the number, not the sign, in order to balance it. So this will be H2S, okay? And this is how I'm gonna be writing the formula. H2S, it's hydrosulfuric acid. If we now check once again the charges, we will see that the sum of the charges is 0. And this is a binary acid. This procedure of crossing charges should be done in all the compounds in order to check that the sum of the charges is 0, okay? If it is not 0, we have to cross charges in order to do it. Let's see the next example. We have H2SO4. I know for sure that it will be a tertiary acid. Why? Because we have 3 elements, or we have oxygen also, and the first one is H, so this is an acid. So what I will know, what I have to look in tertiary acids, I have to look for the polyatomic ion, okay? So SO4, let's look in the chart. SO4, here we have it, and I will point it out with blue here, okay? SO4, what is it? It's a little bit at the top. Let me just put it at the top. Here we have SO4 here is sulfate, and it has a charge of -2. Okay, let me just erase this of tertiary acids so you can see it. Here we have it. Okay, SO4 has a charge of -2. Okay, so this will help me to check if the charges are balanced. Okay, so let's go back to the example. Okay, I'm gonna write here tertiary, well, just a T. So the name of this compound, since it is sulfate, we said that in the form of an acid, sulfate changed to sulfic. Okay, so this will be sulfic acid. You can also find it as sulfuric, and it will be correct also, okay? Sulfic or sulfuric acid. Remember that when we have tertiary acids, we do not write the prefix hydro in the name. Okay, let's make our next example. In our next example, we have perchloric acid, okay? Since we do not have hydro in the name, I know that it would be a tertiary acid, okay? I know that in the formula, it will start with an H, okay? What I have to search for is what is perchloric, or which was a polyatomic ion before perchloric, okay? Just let me erase this so we can have more space, okay? So if we have now perchloric, minus the H. If I have now perchloric, okay, it means that before it was perchlorate, okay, because remember that ate changed to ic when we have the form of an acid, okay? So we have to find in our chart for what is the formula of perchlorate. Okay, so if we go to the chart, we will see, and I will point it out with blue. Okay, perchlorate is the first one that we have here in chlorates. Here we have it. Okay, so perchlorate is ClO4. Okay, let me just erase it. Here you can see it, ClO4 with a charge of -1. Okay, so this is what we have to write in the formula. So this will be HClO4. And since it has a charge of -1 and hydrogen has a charge of +1, the sum of our charges is 0, so we keep it like that. It is balanced, okay? And this will be also a tertiary acid. Okay, let's look to our next example, sulfurous acid, okay? Since we do not have the prefix hydro in the name, I know that it's not a binary acid. This is also a tertiary acid, okay? I will go a little bit faster. It starts with an H because it is an acid. What I have to search for is for the ending O's, what was before. So before O's, it means that it was ite. So I have to search for sulfite in my chart in order to know how sulfite is going to be written. Okay, so if I search for sulfite, where is it? Here it is, and I will point it out with blue. Sulfite is here. I said with blue. Okay, with blue. Sulfite, it's SO3 with a charge of -2. Okay, and that's the SO3 with a charge of -2 is what I have to write in the formula. Okay, so this will be H, okay, SO3. Now, since SO3 has a charge different from the charge that has hydrogen, we have to check and balance it, okay? So we know that sulfite is SO3 with a charge of -2. So check what I'm gonna be writing here at the bottom. I have H with a charge of +1, okay? And then I have SO3 with a charge of -2. +1 here. I have that the sum of my charges here, this +1 that I'm pointing out with yellow, okay, point it out, not erasing it. Let me just write it once again. It's H +1 and then it's SO3. Okay, so once again, this +1, if I add it to this -2, it is not the sum of my exponents equal to 0. So what I have to do is I have to cross charges. What I will do is I will pass the number, not the sign, to the bottom of the other element. So I will pass this number 1 right to the bottom of SO3, this number 2 right to the bottom of H, only the number, not the sign, in order to balance. So my final compound will be H2, and that's what I'm gonna be writing here, and number 2, SO3, and we can write parentheses 1. Well, normally when we have a number 1, outside of the parentheses, we can remove the parentheses and leave it in blank, okay? But what we do have to write is the number 2 of the hydrogen, okay? And that's sulfurous acid. Let's go to the next one. The next one says H3N. I know that it's not a tertiary acid because we do not have oxygen or we do not have 3 elements. We only have 2 elements. So this one will be a binary acid, okay? In binary acids, we know that in the name, I will write the prefix hydro. So this will be hydro, nitric, and the word acid. And this is a binary acid. So binary acids are a little bit more easier to name than the tertiary, okay? And finally, the last compound, we have 3 different elements. One of them is oxygen. So this will be a tertiary acid, okay? I know that in tertiary acids, we do not write the prefix hydro. What we have to look is for the ending of the polyatomic ion. So I have to search in my chart for ClO4. Okay, ClO4, and I will point it out with blue here. Okay, ClO4, it's here, and it's perchlorate. Here is it, ClO4. Oh, we already have it, perchlorate, okay? So what I will do is the example that we have here at the bottom. So the name of this will be with red because it's tertiary, perchloric acid. I hope that with this you get a little bit more understandable how to name binary acids and tertiary acids.